Anyway, so starting off from the start, we've got the input side here. This comes from the charger, and I'm going to be using a 230 watt charger here. And this goes through this sort of ideal diode, or what do you want to call it. It's just some MOSFETs and a little gate driver and stuff. And that's because this piece here, switching regulator, which takes the 19 volts down to 14 and a half. It's not fully isolated, so it kind of goes backwards when you've got the batteries connected. So this is outputting about 13 volts or whatever, and it was causing issues with the charger. So this piece here prevents that from happening. Yeah, so like I said, this one just takes the charger input and knocks it down to 14 and a half volts. Currently got the current just set to maximum. I need to tweak it because it gets a bit too hot with a bigger charger. Then that goes up to the batteries. Now I haven't decided if I want to keep one battery or two. So this is 20 amp hours together. Works out to be about, with losses and stuff, just call it 200 watt hours, which is more than what the console needs to run for a reasonable amount of time. I think you'd probably get about 2 hours, 2.5 hours out of it, maybe closer to 3. It depends what you're doing. The console runs at about 80 watts maximum during a game, just during Halo 2. So yeah, that goes from this to the batteries. These are LiFePo lithium iron phosphate batteries, so they have their own BMS inside and everything. So they have over voltage protection, under voltage protection, and temp protection as well, temperature. So I'm just essentially just bulk charging them. It's fine. I just let them work it out themselves, and it's not exactly like a full-time thing in terms of, it's not like a solar setup or anything, so I don't really need a proper charge controller for them. They'll be fine. Then we got a split off here from the output of this, which is essentially just from now, it's just a charger. It connects the batteries up to this. This is just a normal DC to DC converter, but it takes 8 to 40 volts input, and it constantly outputs 12 volts at 10 amps, which is more than I need. And that's because the voltage range of these batteries is from 10 volts to 14 and a half. And with the Xbox, or with the power supply I've got here, the 12 volt rail isn't very well regulated. So if it drops below, well, the way the regulation works on this one is there's no boost function, it's only buck regulation. So as soon as the input voltage drops below 12.5 volts, this doesn't output 12 volts properly, and the Xbox needs 12 volts for most of the function of it. In testing, if it drops well below 12, it drops down to like 11 or 10, then you start getting really bad like artifacting and stuff, and it's just unstable. So that's why I put this in between, so that way this is always just getting the right voltage it needs. Yeah, moving on to the main power supply for the console. I just took a drawing that was online of a ATX to Xbox conversion using a buck regulator and 2 transistors, and I just made a little PCB I ordered it through JLC PCB, populated it, put a little buck regulator on there, and then that controls all the signaling. Because the Xbox is inverted to a normal ATX, so instead of pulling high, it pulls low. Basically just inverts the signals. And then I've changed the pin out. Even though it's a standard 20 pin connector, the pin out's completely different to ATX. Like you got a 12 volt, all the red ones are 5. I think the blue is the PS on, and then you got like PSOK and 3.3 volts. And what's interesting with the Xbox is there's only really, I think one, apart from the hard drive, there's only one or 2 pins dedicated for 12 volts. Everything runs off the 5 volt rail. That's why the 5 volt rail is so chunky. Its maximum rating is like 20 amps or something. It's crazy. I did have another DC to DC converter, and I was going to run the 5 volt rail separately from this, but everything I've tried on it, this power supply seems to run it fine. And that's also with an optical drive connected, but a 2.5 inch hard drive, not a 3.5 inch. So maybe with everything maxed out on the console, like stock, as in like 3.5 inch hard drive, I've got an old one, a bunch of controllers, every memory card slot used up on the controllers, headsets and all that sort of stuff, then maybe you would hit the limit of what this thing can output. But under normal circumstances and the way I'm using it, without an optical drive, it doesn't even get hot. It's fine. So yeah, the input here just comes from the output of this DC to DC converter. 12 volts in, all the voltages out. It's got all the power supply control stuff here, and that just pulls the load to turn this thing on, and the PSOK and stuff is different voltages to what ATX uses, so it just does a bit of conversion there. That's what the buck regulator is for. And yeah, so that's the entire power side of it. But like I said, I don't know if I'm going to keep 2 batteries for this. I reckon you could get away with 1. Lithium iron phosphate is a bit less, has a bit less energy density to lithium ion or lithium ion polymer batteries. So if you wanted to build a proper portable that you could probably walk around, like carry around, like handheld, I reckon you could probably get away with maybe 10, 12 amp hours of like LiPo batteries, but charging them and stuff is more difficult and all that sort of stuff, and the safety things with it. And they're a lot more expensive. These 2 batteries together, I got them on sale for like $100 Australian, which is like $80 US, and they're genuine capacity ones. They're not fake ones. And they've got all the protection circuitry inside. I considered pulling them apart and making a new pack, but I want to keep things simple, and having it this way means that you can just easily replace them. Alrighty, moving on to the board. I'm not super experienced with trimming boards, so I haven't trimmed this. I was considering it, but not sure how many layers this has. I think it's got 5 or 6 layers, so, and it's fairly well, it's fairly dense as it is. As you can tell, like all these traces for the IDE and stuff are pretty close to the edge, and there's stuff here. You could probably trim up here and down here, but it's really not make much difference. Because the batteries themselves are the biggest part of it. The actual console is fairly flat. I did replace these caps up here because they were getting a bit broken, they were a bit bulgy, so I just replaced them with newer ones which are shorter. And probably the biggest change I've done here is the heatsink. This is just an Xbox 360 heatsink. I think the first generation 360 heatsink, because I had 2 for the graphics card. There was this one, and there was one with a heat pipe, so I just grabbed this one. I think it's off an arcade or something. So the top of the GPU and the top of the CPU aren't perfectly the same height, but what I found is because the GPU is normally passively cooled, focusing more on getting pressure on the CPU, I've had no issues with temps. Running this at I think 1.5 or 2x fan speed, which isn't very loud at all, keeps the CPU under 65 under load, which is fine. That's open air like this. I don't know how it'll do once I figure out how to make a housing for it. It's not even screwed in, it's just siliconed in like that, and there's thermal paste there. That's just some double-sided tape I was using to hold it in the meantime. As terms of the hard drive, it's just a 2.5 inch drive for now, 2 terabyte one. I just wrapped it in some tape just to make it easier to mount here, and I'll probably leave it here like that. And I've got a really short 80 wire IDE cable because there's issues running the 40 wire version. There's too much interference and it causes problems with the drive. It's really slow. And then I've just got one of these cheapo SATA to IDE converters, the standard one, and I just, instead of using a big 4-pin connector, I've gone down to a 3-pin JST and kept the original SATA connector. I was originally going to hard mount this and then use a SATA cable, but again, there was too many issues with interference on the IDE side of things, and it just wouldn't load all the time, throwing up different errors and stuff, so I just put it back the way it was. This orange wire is just where there's a broken trace from changing out the socket. Up here, this is just a standard 1.4 board. I might upgrade the RAM on it actually, because I'd like to be able to do as many 720p mods to the games as possible, because they're all going to load off the hard drive, and it's just nicer to have a higher resolution, but they all require at least doubling the RAM. Not all games support updating the resolution, but there's a fair big list of them, and I think at least half of that list works fine on the stock CPU. I think you can overclock these now. I can't remember. This is just the standard. I think it's 700 megahertz or whatever it was. Pentium 3. Here we have a Wii to HDMI. Pretty standard. I'm going to change out these wires though. There's a bit of noise on them, which shows up in the image. I did fiddle with the, there's a 75 ohm resistor on the board here for adjusting the chroma, and I've changed that out. I think I knocked it down to 40 ohms, or maybe it was above 40 ohms, above 75, I can't remember. But the black levels on these aren't very good, so I just tweaked that a little bit, made it a little bit brighter, and it's not ideal, but it'll work for a portable. That's fine. Just some dark scenes are a bit too dark, and not all games let you change the gamma and stuff. So yeah, we're just pulling 5 volts from here. This is the 5 volts that was going to, I think it feeds into the video encoder. And what's something interesting when I was working on this was I've blown about 3 of these focus encoders. So I had to pull them off parts boards because I had a bad Wii to HDMI converter. There's nothing physically wrong with it, it just kept on breaking these. So if you're in the market, you can actually still get these on Alibaba, but the not the one with Macrovision. So there's 2 versions of this chip. There's the 454, which was a custom one from Microsoft, and it has built-in Macrovision. But you can actually take the sort of consumer, I guess, side of it, not the custom one, which doesn't have built-in Macrovision, which means nothing these days. So. And apparently they're fully pin compatible, so you can just drop them in if you ever break one. Yeah, standard sockets here and everything, and keep all that. That's sort of the profile of it. With these batteries on their side, it's about the same thickness as an original Xbox is, so that's sort of your idea of things. So yeah, I'm gonna whack this together and I'll just give you guys a quick look on the TV. I haven't got a panel made up yet for it. I need to get a EDP converter for it, so I can use a 1080p panel. But yeah, the biggest thing I've hit so far that I can't do is work out how to make a housing for it. I'm thinking like still doing like a laptop style because it's the easiest to make. It's gonna be way too heavy and too big to be handheld. Yeah, I was thinking like maybe a 15-inch screen's the smallest you can go if you want to do split screen, 4-player or anything like that. So I don't know, leave a comment down below if you have any suggestions, or if there's any kind of shell or housing that I can buy already done that I can just modify a bit, because yeah, designing that sort of stuff isn't my strong suit. Yeah, all right, I'll be back in a sec. Alrighty, so this is how it looks all wired up. Got the hard drive here, HDMI there, that's the batteries. This piece isn't being used at the moment for the charger, so that's just sitting there. Step down regulator, and both these batteries each have their own fuse. And that's all going from there into there, and then through the power supply into the console. Got a controller plugged in here. And the goal here is to make the entire thing work with the original power button on the Xbox. I don't want to have any switches or anything to turn things on. Everything has to be controlled by the original power on button on the console. That's my main goal. So then it's more like a product then, isn't it? So I'm just going to short these pins out because I don't have the button connected. Lovely reflection. It's got an EvoX BIOS, which deletes the optical drive check. And now we're just loading into Unleashed X. Let me see if we can turn the brightness down. There we go. There's a bit of a delay here. It's not the Xbox, it's because it's trying to play a video which isn't there anymore. And there, we're in 720p at the moment. And you can see the specs here. The board temp's 30, CPU's 39. We've got 2TB drive. Some of these games don't load because they're bad rips, so let's see what works. Does Burnout 3 work? I don't think Burnout 3 works. Family Guy works, and Ford Racing, sorry, let's try Doom 3 actually. I think Doom 3 doesn't load. I think it crashes back to the menu. They're all pretty crap rips. Oh no, this one's working. So yeah, because it's not modded, this game, it's still in 480p. And also this BIOS has the 480p patch on it, because all the games I have are PAL, so most of them are 480i. So it's just better. Loading. I haven't played Doom 3 off the hard drive before, so I don't know. Halo 2 loads pretty fast too. I don't know if it's putting any files onto the drive or something. Because Doom 3, even though it's a small game, probably has a lot of files it needs to save to the disk. For memory, it has the video memory requirement is 64 megs, which is like the entirety of what the Xbox has for everything. So, alrighty, so we're in the game now, and the contrast isn't the best. It looks fine to me, but all these lights in the room, and I had to change the exposure on the camera, so I'm trying to do this one-handed. Welcome to Mars. Man, this game didn't age very well. Okay, I'm going to try and do an in-game reset. I don't think I can do this one-handed. Give me a second. There we go. It's my favourite feature of these BIOSes. Boom! And we should be back at the dashboard again. But yeah, there it is. Some other features I want to add to this. I want to add like maybe Wi-Fi, just use a router or something. I've got some small routers here with like OpenWRT or something on them. And then you can do like connecting to a wireless network, because it is a portable, so you'd want it to connect wirelessly to stuff, especially with the new Xbox Live, stuff, which is coming out, but I'm not too sure 100% how that works. I might need to use a computer. Maybe I'll use a Raspberry Pi or something, like a Pi 4, have it create a local network for this to connect to. But it'd be cool to have like a router installed in it, so then you can like connect it to other Xboxes and do like LAN party and stuff. But yeah, definitely gonna upgrade the RAM. That's probably a necessity if I want to change the resolution of the games. And yeah, I just need to work out how to make a housing for it, and then it's pretty much done. I didn't work on this for a few years, moving and stuff, so all this progress was probably made in the last year. Just every couple of weeks, just spend a couple of hours on it. But yeah, if you have any questions about it, just leave a comment down below. If you have any suggestions on what I could use to make a housing for it, I'm thinking still laptop style, just because the size of it, it's the only thing that's going to work. And yeah, if you want to see more videos about this sort of DIY stuff, just let me know. Yes. Anyway, until next time, see ya.